Question 1. If f of x is equal to mod of x minus 2, then we're given four options, that is limit x approaches to right of 2, fx is equal to 0, not equal to 0. B. Limit x approaches to 2 from the left hand side, which is fx is not equal to 0. C. Limit x approaches to 2 from the right hand side fx, which is not equal to limit x approaches to 2 from the left hand side of fx. D. F of x is continuous at x is equal to 2. Here f of 2 is equal to 0 when limit x approaches to 2 from the left hand side, that is minus f of x equal to, we can write it as limit h approaches to 0 f of 2 minus h, which is equal to limit h approaches to 0 mod of 2 minus h minus 2 mod, which is equal to 0. Same from the right, we take limit x approaches to 2 f of x equal to limit h approaches to 0 f of 2 plus h, which is equal to limit h approaches to 0 mod 2 plus h minus 2, which is equal to 0. So here if we see, it is a continuous at x is equal to 2. Therefore we conclude that f of x is continuous at x is equal to 2. Therefore option D is the correct answer. Question 2. If the derivative of the function f of x is everywhere continuous and is given by f of x bx square plus ax plus 4 for x greater than equal to minus 1 and ax square plus b x less than minus 1, then we are given four options for the value a and b. So for the continuity, we know that the left hand limit should be equal to right hand limit. So we take the function, that is f of x bx square plus ax plus 4 equal to ax square plus b. Now we can substitute the value of x, which is greater than equal to minus 1, for LHL. So we get as b minus of 1 the whole square plus a minus of 1 plus 4 equal to a minus of 1 the whole square plus b. Solving this, we get as b minus a plus 4 equal to a plus b. Further solving, we get 2a equal to 4, where we get a is equal to 2, and for solving b, we get b is equal to 3, which is our option A. Therefore option A is the correct answer. Question 3. The function f of x log 1a plus x minus log 1 minus bx upon x is not defined at x is equal to 0. The value which should be assigned to f at x is equal to 0 so that it is continuous at x is equal to 0 is, we are given four options. Since the limit of a function is a plus b as x approaches to 0, therefore to be continuous at a function, its value must be a plus b at x is equal to 0. Therefore f of 0 equal to a plus of b, which is our answer matches with option B. Therefore option B is the correct answer. Question 4. Let f of x is equal to x raised to cube plus x square minus 16x plus 20 by x minus 2 the whole square if x is not equal to 2, and k if x is equal to 2. If x be continuous for all x, then k is equal to, we are given four options. For continuous, limit x approaches 2 f of x equal to f of 2 equal to k, where we get k is equal to limit of x approaches to 2 x cube plus x square minus 16x plus 20 by x minus 2. So we get limit x approaches to 2, x square minus 4, x plus 4, x plus 5 upon x minus 2 the whole square. Further, if we substitute the value of x as 2 in this, we get 7, which is our option A. Therefore, option A is the correct answer. Question 5. Let f of x square plus k when x is greater than equal to 0 and minus x square minus k when x is less than 0. If the function f of x be continuous at x is equal to 0, then k is equal to. We are given 4 options. Here limit x approaches to 0 from right hand side, f of x is equal to k, and limit x approaches to 0 from left hand side, we get f of x is equal to minus k, and for f of 0 is equal to k. But f of x is continuous at x is equal to 0, so therefore k must be 0. Therefore option A is the correct answer. Question 6. If in order that the function f of x is equal to x plus 1 raised to 1 by x is continuous at x is equal to 0, f of 0 must be defined as, we're given 4 options. Limit x approaches to 0, f of x is equal to f of 0, which is equal to limit x approaches to 0, 1 plus x raised to 1 by x. If we substitute x as 0, we get equal to e. Therefore f of 0 we get as equal to e, which is our option B. Therefore option B is the correct answer. Question 7. If f of x is equal to x square by a minus a when x is less than a, 0 when x is equal to a, then a minus x square by a when x is greater than a. We have given 4 options. We have f of a is equal to 0, limit x approaches to a from left hand side, f of x is equal to limit of x approaches to a from the left hand side, we get x square by a minus of a, where we get a that is equal to limit h approaches to 0, we get at a minus h the whole square by a minus a, which is equal to 0. Same for the limit approaching, that is x approaching from the right hand side, we get f of x is equal to limit h approaches to 0, a minus a plus h the whole square by a, where we solve this, we get 0. Therefore hence it is continuous at x is equal to a. So if we see our option B, that is f of x is continuous at x is equal to a, so therefore B is the correct answer. Question 8. If f of x is equal to e raised to 1 by x when x is not equal to 0, then 0 when x is not equal to 0, therefore then we have given 4 options. We have f of 0 is equal to 0, so limit x approaches to 0 from left hand side of fx is equal to limit h approaches to 0 e raised to minus 1 by h, which is equal to 0, and limit x approaches to 0 from the right hand side, we get f of x equal to limit h approaches to 0 e raised to 1 by h, which is equal to infinity. Therefore hence the function is discontinuous at x is equal to 0. Therefore if we see option C, that is f of x is discontinuous at x is equal to 0, is the correct answer. Question 9. If f of x is equal to x square minus 4x plus 3 by x square minus 1 for x is not equal to 1, and 2 for x is equal to 1. Then we are given 4 options. We have f of x is equal to x square minus 4x plus 3 by x square minus 1 for x is not equal to 1 and for 2 x is equal to 1. So we solve for f of 1 which is equal to 2. We get f of 1, that is from right hand side, that is limit x approaches 1 from the right hand side. We get x square minus 4x plus 3 by x square minus 1, which we get as limit x approaches to 1 from the right hand side. We get x minus 3 upon x plus 1, which we get as minus 1. For f of 1 from the left hand side, we get limit x approaches 1 from the left hand side, x square minus 4x plus 3 by x square minus 1, which we get as minus 1, where we see f of 1 is not equal to f of 1 from the left hand side, which is equal to f of 1 from the right hand side. Therefore, LHL is equal to RHL, which is not equal to f of 1. Hence, the function is discontinuous at x is equal to 1. Therefore, option C is the correct answer, which is f of x is discontinuous at x is equal to 1. Question 10. If f of x is equal to sin x upon x plus cos x when x is not equal to 0, 2 when x is equal to 0, then we are given 4 options. We have f of 0 from the right hand side, which is equal to f of 0 from the left hand side equal to 2. So we have f of 0 is equal to 2. So f of x is continuous at x is equal to 2. Therefore, option C is the correct answer. Question 11. The value of k so that the function f of x, that is k into 2x minus x square, where x is less than 0, and cos x when x is greater than equal to 0, is continuous at x is equal to 0. As we are given 4 options in this. F of 0 from the left hand side is equal to limit of x approaches to 0 from the left hand side, k 2x minus x square, which is equal to 0. Same for f of 0, limit x tends to 0 from the right hand side, cos x, which is equal to 1. So for f of 0, cos x is equal to 1. Hence, no value of k can make f of 0 from the left hand side, that is equal to 1. Therefore, we see there's no value for k in this, so therefore D option, that is none of this, is a correct answer. Question 12. If f of x is equal to x upon e raised to 1 by x plus 1 when x is not equal to 0, then 0 when x is equal to 0, then we are given 4 options. For f of 0 is equal to 0, for f of 0 from the left hand side, that is limit h approaches to 0, we get minus h upon e raised to minus 1 by h plus 1. If further we solve, we get limit h approaches to 0, we get minus h upon 1 plus 1 by e raised to 1 by h, which is equal to 0. So therefore, f of 0 from the right hand side, we get limit h approaches to 0, we get h upon e raised to 1 by h plus 1, which is equal to, we get 0. Therefore, f of x is continuous at x is equal to 0. if we see, we get 0 at both the side, that is LHL and RHL. Therefore, C is a correct answer. Question 13. If f of x is equal to 1 plus 2x raised to 1 by x for x not equal to 0 and e square for x is equal to 0, then we're given four options. Limit x approaches to 0 from the left hand side of f of x is we get as limit x approaches to 0 1 plus 2x raised to 1 by 2x. Further, we get this as, which is the limit of 1 plus 2x raised to 1 by 2x is raised to square. So we get this as e raised to square. Therefore, if we see f of x where lim x approaches from the left hand side of 0, f of x we get as e square. Therefore, option B is a correct answer. Question 14. Let f of x is equal to 1 when x is rational, 0 when x is irrational. The limit x approaches to 0, f of x is, we're given four options. So given that f of x when 1 when x is rational, 0 when x is irrational. So for LHL, limit x approaches to left hand side of fx, limit we get h approaches 0 from right hand side, that is f of 0 minus of h equal to 1, where 0 minus h is a rational. Same for RHL, limit x approaches to 0 right hand side of fx is equal to limit h approaches to 0 f of 0 plus of h, that is equal to 1, where 0 plus h is rational. Hence LHL equal to RHL equal to 1, which is our option B. Therefore, option B is the correct answer. Question 15. For the function f of x is equal to x cube minus a cube upon x minus a, where x is not equal to a, and for b, x is equal to a. If f of x is continuous and x is equal to a, then b is equal to, we're given four options. For LHL, that is the limit x approaches from the left hand side to a, f of x is equal to limit h approaches to 0 a minus h the whole cube minus a cube upon a minus h minus a. So we write this as limit h approaches to 0 a cube minus h cube minus 3ah into a minus h minus a cube upon a minus h minus of a. Therefore, limit h approaches to 0, we get minus h square plus 3a a minus h minus of h. For this one, we get limit h approaches to 0 h square plus 3a a minus h, which is equal to 3a square. Therefore, we get b is equal to 3a square, which is our option C. Therefore, option C is the correct answer. Question 16. If at which points the function f of x, that is at which points the function f of x is equal to x by x, where brackets is a greatest integer function is discontinuous. We have given four options. For one, when x is greater than equal to 0 and less than 1, f of x doesn't exist for x is equal to 0. Here for 2, also the limit x approaches to 1 from the right hand side of f of x, and limit x approaches to 1 from the left hand side f of x does not exist. Hence f of x is discontinuous at all integers and also in 0, comma 1, which is our option B. Therefore option B is the correct answer. Question 17, for the function of f of x is equal to sine square ax upon x square, where x is not equal to 0, which one is A? When x is equal to 0, true statement are given options. Your limit x approaches to 0, f of x is equal to sine square ax upon x square into a square, which we get as a square, for f of 0 equal to 1. F of x is discontinuous at x is equal to 0, and when when a is not equal to 0. Therefore if we see option B, f of x is discontinuous at x is equal to 0 when a is not equal to plus minus of 1. Therefore option B is the correct answer. If f of x were minus x square when x is not equal to 0, 5x minus 4 when x is greater than 0, less than equal to 1, 4x square minus 3x when x is greater than 1, less than 2, then 3x plus 4 when x is greater than equal to 2. We are given 4 options. Limit x tends to left hand side from approaches to 0 from left hand side, we get f of x is equal to 0. Same for f of 0, which is equal to 0. Limit x approaches to 0 from the right hand side, we get f of x equal to minus 4. So if we see f of x is discontinuous at x is equal to 0, so limit we see x approaches to 1 from the left hand side, we get f of x is equal to 1, and limit x approaches to 1 from the right hand side, we get f of x is equal to 1. So for f of 1 is also equal to 1. So hence f of x is continuous at x is equal to 1. So also limit, if we see limit x approaches to 2 from the left hand side, that is f of x is equal to 4 to the whole square minus 3 into 2, we get as 10. Same for f of 2, we get as 10. Now for the limit x approaches to 2 from the right hand side, we get f of x is equal to 3 into 2 plus of 4, which is equal to 10. Hence f of x is continuous at x is equal to 2. Therefore we see that is option B, that f of x is continuous at x is equal to 2. Therefore B is the correct answer. Question 19, if f of x is equal to sine inverse of mod x when x is not equal to 0, 0 when x is equal to 0, then we're given 4 options. For limit x approaches to 0 equal to sine inverse of 0, we get as 0, and for f of 0 as we get as 0. Therefore f of x is continuous at x is equal to 0. So that is, we see option C is the correct answer. Question 20, if f of x is equal to sine 2x by 5x when x is not equal to 0 and k when x is equal to 0 is continuous at x is equal to 0, then k when x is equal to 0, then value of k will be given. We write limit x approaches to 0, f of x is equal to limit x approaches to 0, 2 sine 2x upon 2x into 5. Further, we get 2 by 5, which is equal to k. Therefore option B is the correct answer. Question 21. If f of x is equal to 1 plus x square when 0, where x is greater than equal to 0 and less than equal to 1, 1 minus x when x is greater than 1, then we're given four options. Limit x approaches to 1 from the right hand side of fx is equal to 0, and limit x approaches to 1 from the left hand side f of x is equal to 1 plus 1, which is equal to 2. Hence f of x is discontinuous at x is equal to 1. Therefore, we see option C is the correct answer. Question 22. If f of x is equal to x square minus 1 upon x plus 1 when x is not equal to minus 1, then minus 2 when x is equal to minus 1, then we have given four options. For limit x approaches to 1 from the left hand side, f of x is equal to minus 2, and for f of minus 1 is equal to minus 2. Therefore, we see that limit for x approaches to minus 1, we get at f of x is equal to minus 2. For limit x approaches minus 1 from the right hand side, we get fx is equal to minus 2, and for f of x is continuous at x is equal to minus 2. Therefore, we see all of the above are the correct answer. Therefore, option D is the correct answer. If f of x is equal to 5 by 2 minus x when x is less than 2, when 1 x is equal to 2, then x minus 3 by 2 when x is greater than 2. We give four options. Limit x approaches to 2 from the left hand side of fx is equal to half, and limit x approaches to 2 from the right hand side f of x is equal to half, for f of 2 is equal to 1. Hence f of x is discontinuous at x is equal to 2. So therefore option B is a correct answer, which is f of x discontinuous at x is equal to 2. Question 24. If f of x is equal to mod x minus a upon x minus a when x is equal to not equal to a and when x is equal to a, then we're given four options. Limit x approaches to a from the left hand side, that is f of x, we get as minus 1, and for limit x approaches to a from the right hand side, we get f of x is equal to 1. Therefore f of a we get as 1. Therefore f of x is discontinuous at x is equal to a. Therefore we see option B is the correct answer. Question 25. If g f of x is equal to mod sin x and f gx is equal to sine root the whole square, then we are given four options. For f of x should be square trigonometric function and g of x should be square for root function. Therefore f of x is equal to sine square x and g of x is equal to root x will satisfy the given condition. Therefore, we see option A is the correct answer. Question 26. If f of x 1 when x is greater than 0 and less than equal to 3 pi by 4, then 2 sine 2 by 9 x when x is greater than 3 pi by 4 and x is less than pi, then we're given four options for f of x. Here f of 3 pi by 4 is equal to 1, and limit x approaches to 3 pi by 4 from the left hand side, we get f of x is equal to 1. Same for the limit x approaches to 3 pi by 4 from the right hand side, f of x we get as limit h approaches to 0, 2 sine 2 by 9 3 pi by 4 plus h, which we get as 2 sine pi by 6 equal to 1. Therefore, hence f of x is continuous at x is equal to 3 pi by 4, which we see that is option C is the correct answer. Question 27. If f of x is equal to x sin x when x is greater than 0, less than equal to pi by 2 sine pi plus x when x greater than pi by 2 and less than pi. Then we're given four options. For limit x approaches to pi by 2 from the left hand side, f of x is equal to pi by 2. Same for the limit x approaches to pi by 2 from the right hand side, we get f of x is equal to minus pi by 2. So for f pi by 2, we get as pi by 2. Therefore, f of x is discontinuous at x is equal to pi by 2, where we get right hand side as minus pi by 2. Therefore, option A is the correct answer. Question 28. If f of x is equal to 1 minus cos 4x upon x square when x is less than 0, and a when x is equal to 0, and root x upon root 16 plus root x minus 4 when x is greater than 0 is continuous at x is equal to 0, then the value of a, b, we take limit x approaches to 0 from the left hand side of fx is equal to limit x approaches to 0 from the left hand side 2 sine square 2x upon 2x the whole square into 4, which is equal to 8. Therefore, limit x approaches to 0 from the right hand side of f of x is equal to limit x approaches to 0 from the right hand side of root 16 plus of root x plus 4, which we get as 8. Therefore, we get value of a when x is equal to 0, we get as 8. Therefore, option A is the correct answer. Question 29. If f of x is equal to ax square minus b when x is greater than or equal to 0, x is less than 1, when and 2 for when x is equal to 1, x plus 1 when x is greater than 1 and less than or equal to 2, is continuous at x is equal to 1, then the most suitable value of a and b are, we're giving options, and a, the value of a and b. So we take limit x approaches to 1 from the left hand side of f of x is equal to a minus b, and limit x approaches to 1 from the right hand side, we get f of x is equal to 2. So we get a minus b equal to 2. All the given sets of a and b make f of x continuous at x is equal to 1. Therefore, answer for a and b, which is a is equal to 2, b is equal to 0, is correct at x is equal to 1. Also b and c also correct at x is equal to 1. Therefore D, that is all of the above, is the correct answer. Question 30. If f of x is equal to x square plus 3x minus 10 upon x square plus 2x minus 50 when x is not equal to minus 5, and a when x is equal to minus 5 is continuous at x is equal to minus 5, then the value of a will be, we're given four options. So limit x approaches to 5 for f of x is equal to x minus 2 into x plus 5 upon x plus 5 upon x minus 3, which is equal to, when we solve this, we get minus 7 upon minus 8, which is equal to 7 by 8. Therefore, option B is the correct answer.